Alrighty, so today we are going to be practicing the grouping method, and you guys are going to see I'm going to teach you another way that you can factor. So you probably learned grouping in Algebra 2, but I'm going to show you a different way to use this. Alright, so just to start with using the grouping method, we want to be able to factor out a GCF. And again, sometimes the greatest common factors end up being binomials. So we're going to write out each of the following expressions as a product. So we're going to write it out as a product of two binomials by factoring out the common binomial factor. So really, like, what the heck does that mean? Well, if we look at the first one, so part A we'll do together, we have 2x times x plus 5 plus 3 times x plus 5. The 2x and the plus 3, notice how they're both being multiplied by x plus 5. They share that factor. So I'm going to take out the x plus 5. Okay, so I'm going to take out the x plus 5. And really what that does now, I'll write it like this. If I divide this out by x plus 5, divide this out by x plus 5, well, that goes away and that goes away. And I'm left with 2x plus 3. Okay, so I took out that GCF, brought out the GCF, and I was left with the 2x plus 3. Let's take a look at another example. Let's take a look at letter B. All right, so very similarly here again, I see that I have a 2x minus 1 in common for both, and what's remaining ends up becoming my other factor. So I'll write out I have x plus 5 times 2x minus 1. Again, they both share this factor, so we take it out. That's the GCF. Okay, so maybe you would prefer the GCF out front like this. That's normally how we've done it. So right out front like this, times the whatever's remaining, which was the x plus 5. Okay, I'll do one more and then I want you guys to try. So for letter D, again, same concept. I notice that they both share a 4x plus 1. They're being multiplied. What's remaining is this 3x plus 7. So again, take out the GCF, take out the 4x plus 1. All right, so take out the 4x plus 1 on both. So I factor out that 4x plus 1 on both, and you see what's remaining is 3x plus 7. So hopefully now we're starting to get the hang of this. I want you guys to try C, E, and F. Now I'm going to go through letter H with you guys, but you're going to see something very similar going on between H and E. So pay attention here. Okay, so first thing I notice is that we have that x plus 10 in common. And then I have, let's see what's remaining. I have this 4x and, I just have a plus. What's really in front of the plus, guys? What can I always distribute? We have a plus 1 here, right? There's really a plus 1. So we're not going to do that distribution, but I just wanted to show you that as an example. Okay, there's a plus 1 remaining. So when I factor out that GCF of x plus 10, I'm left with 4x plus 1. All right, so this will be useful to use when you guys complete C, E, and F. All right, moving right along, let's go over to the next page. All right, so now we're on page 26. So just a little bit of definitions here. So when we factor a polynomial by grouping, we always want to look for the GCF first. Always look for a GCF first. We're going to split the terms into groups as we did in the previous page. We're going to factor each using their separate GCFs. And then we're going to find that there must be a common binomial factor between them. So if I just look at this first example, we'll do this together. I'm going to separate them by 2. So we'll do the first 2 and then the last 2. So from looking at these first 2 numbers, we have 20n squared plus 5n. I notice the GCF is 5n. So we're going to factor out a 5n. 20n squared divided by 5n, well, that's 4n. 5n over 5n, well, that's 1. Okay, so that satisfies that. Let's take a look at the second one, second set of numbers. 12n and 3, they both have 3 in common, but it's a positive 3. I always include the positive. You need that. Okay, and 12 divided by 3 is 4. Don't forget the n. And I'm left with 1 because 3 divided by 3 is 1. Okay, you could look at it as like that pretzel method I talked about earlier. Really, you can look at it like that. All right, again, I want to see, yep, these terms are the same. We wanted that. They need to be the same. And then this is what's remaining. That's my remaining binomial factor. So I have that 4n plus 1 times 5n plus 3. All right. Now, a lot of these problems on here are just practice. So let's just take a look at another example. Let's take a look at question number 4 together. So again, we're going to divide out the first two terms and then divide out the second two terms by their unique GCFs. So if I look at the first one, okay, well, I have 2n squared plus 5n. All they share is an n. So let's take out the n. 2n squared divided by n is just 2n. 5n divided by n is just a positive 5 because the n's cancel. Okay, well, let's see. This was a plus in between. All right, let's see. 4n plus 10, they both share a 2. So again, use the pretzel method or heart method, take out a 2, and I'm left with 2n plus 5. Again, guys, these numbers here in the parentheses have to match. If they don't, you did something wrong. And this is what's remaining. So now, again, when I write out my factors, we have 2n plus 5 times n plus 2. Okay, and just to gain some practice, I'm going to have you guys do question 6. I'll post the answer right now because, again, you need to show the work. I want to see the work. You can't just come up with it right off the top of your head. So your final answer here should be 2m plus 5 times 3m plus 2. All right, so you're going to do that one on this page. Moving right along. Next page, page 27. All right, again, just giving you guys more practice. We always look for the GCF for the first two terms and then the last two terms. So from the first two terms... Well, wait a second. I don't see anything in common here. And I don't see anything in common here in the second two terms. So we have to rearrange, guys. You have to rearrange the terms. This one wasn't set up that nice. So I'm going to write 5x plus 20 plus 4y plus xy. Because now 5x and 20, they have something in common. 4y and xy, they have something in common now. So now I can divide out by the GCF of the first two terms and the last two terms. So take out a 5 because they both have a 5 in common. We'll be left with x plus 4. And take out a positive y. And I'll be left with 4 plus x. Now, guys, just notice these are the same. These are exactly the same, x plus 4 and 4 plus x. I could have rewritten this if I wanted to as x plus 4. Okay, it's the same exact thing. And our remaining factor is 5 plus y. All right, so hopefully this helps clarify. Okay, and the next two problems that I would like you to do on this page are questions 12 and 14. Again, just getting that practice. The answer for 12, again, you guys have to show the work. This final answer will not give you credit. I'm not going to take it. I need to see the work. And we have 2a plus 3b times 2 plus b. So write it down, check, make sure your answer matches. All right, moving on. Now we're going to talk about grouping with 3 terms. So this is actually going to be brand new information for you guys. So in the past, what you guys have always done is tricky trinomial. I'm going to show you guys how to factor by grouping. So let's just start off with this first example. If I have 12x squared, right? I want to think of all the factors that multiply to 12x squared. Well, we have 1x, 12x, we have 2x, 6x, 3x, 4x, and then, of course, all of their negative numbers, right? Negative 1x, negative 12x, etc. I'm not going to write them all out. Okay, well, I want to know the factors that are going to add to 8x. So from this set, which of these is going to multiply to that 12x squared but adds to 8x? The only possibility would be 2x and 6x. So what we could do, and now you guys are going to do your double bubble as normal, but I'm going to show you guys just with a simple problem what I mean by factoring by grouping instead of tricky trinomial. Is now you can actually write this as x squared plus 6x plus 2x plus 12. Okay, so this could really be written like this. It doesn't matter the order of the terms in between. Now, what I can do is factor by grouping. Take the GCF of the first two terms, so take out the x, I'm left with x plus 6, and take out the GCF of the second two terms, and I'll be left with x plus 6. Again, we should notice that the x plus 6's, they have to match. Whatever's remaining is our other factor. So this is really x plus 2 times x plus 6. Now you're probably thinking, well, why the heck would I do this if I already know I can just double bubble? I'm just showing you an example because there are going to be harder problems where the number out front of x is not 1, that leading coefficient. Okay, hopefully this example makes sense because now I want to get into the bulk of the problems that we're going to be doing today. So let's go over to the next page. So this method that I'm talking about with, again, factoring by grouping from 3 terms, okay, we call this the term at the end, because you know how you guys did this in tricky trinomial, right? You'd multiply that a value out front here when a wasn't 1. So when a wasn't 1, you multiplied the front to the back. Okay, we're not going to be doing that, where you then brought the constant up, etc., whatever. Okay, what I want to show you guys is how to actually do this now by grouping. So while we still will multiply the front to the back, it's going to be applied differently. So we're going to multiply the first term to the last term, and we call that the master product. So this 1x squared times 5 is really 5x squared. That's the master product. You're going to think of the factors that multiply to the master product. So I have negative x, negative 5x. I have positive x, and then positive 5x. Okay, but I want to find the pair of factors that are going to add to the middle. I want to add to 6x. Well, the only numbers that I can add together to get 6x is x plus 5x. So we're going to rewrite the trinomial now with 4 terms. So I'll have x squared plus x plus 5x. And then again, we can do our factor by grouping. Take out the x, I'm left with x plus 1. Take out the positive 5, and I'm left with x plus 1. Again, I'm showing you guys these examples that are where the a value is 1. So really, you guys could just do your double bubble, but I'm showing you examples that you're comfortable with, so that way when we do start doing the problems where a doesn't equal 1, we're okay with it. All right? So let's actually model that. Let's do question 3 together, so that way you can see what I'm talking about. Like, why am I doing this when I can just double bubble? Okay, so for question 3, immediately I see the a value is not 1. So I'm going to have to factor by grouping. We are not going to do tricky trinomial. I'm showing you guys another way to factor. This is another way to do it. So I'm going to multiply the first term to the back term, and I get negative 10x squared. The whole point of factoring by grouping is we want to turn it from 3 terms to 4 terms. So I need to split the middle. We want to think of a number that's going to multiply to negative 10x squared, but adds to positive 9x. So let's see. Let's think of some factors. We've got negative 10x and positive 1x, or we have 10x and negative 1x. Now again, one of these factors is going to work. Well, negative 10 plus 1 is negative 9. And that's no good because I want positive 9, right? This says positive 9x, so that's out. So it has to be this. I'm going to use these terms to split my middle terms. So I have 2x squared plus 10x minus 1x minus 5. We split the middle. And now that we split our terms, we can factor by grouping. We have 4 terms. Take out the GCF. So I'm going to take out the GCF here, which is 2x. So I have 2x times x plus 5. Take out the negative 1. So I'll take out the negative 1 and I'll be left with x plus 5. You should notice this has all been building on each other. I have an x plus 5 in common, and what's remaining is my last factor. So my 2 binomials is 2x minus 1 times x plus 5. And we're done. We just factor this by grouping instead of using tricky trinomial. Granted, again, if you don't like this method because you've been doing tricky trinomial for years and years, you don't need to do this, but I'm showing you another way to factor. Okay, let's do question 4 together. So I have 3g squared minus 7g plus 2. That a value isn't 1. So I have to factor by grouping. So I'm going to multiply the first term. So the first term gets multiplied by the back term. We end up with 6g squared. Now I want to think, what multiplies to 6g squared, but is going to add to negative 7g? Okay, so we want to multiply again to that 6g squared and add to the negative 7g. So I'm going to start writing out the factors. We have 6g and 1g. I have negative 6g and negative 1g. So if I look at the set of numbers, 6g times 1g, that is 6g squared. But if I add them, that's not going to get me to negative 7g. So that's out because we're trying to add to the middle term. Negative 6g times negative 6g times negative 1g is 6g squared, which was good. And if I add negative 6g plus the negative 1g, I do get negative 7g. So this is our pair. We're going to split the middle with this set of terms. You want to get used to saying split the middle. All right, so now when I write this out, we have that 3g squared minus 6g minus 1g plus 2. So that came from splitting our terms because negative 7g can be rewritten as negative 6g plus negative 1g, or just without the plus. You don't really need it. Okay, we're going to factor by grouping. What is the GCF of the first two and what's the GCF of the last two terms? I see a 3g in common here, so take out the 3g. I'll have g minus, not 6. I'll have 6 divided by 3, so that should be minus 2. Those g's cancel if you want to look at it as like the heart method. Again, in common here, let's see, I have a negative 1g plus 2. Let's take out the negative 1. So I have minus 1 times g minus 2. And here is what is remaining. Oops, right here. So we have 3g minus 1 times g minus 2. And that's it. All right, guys, I'm going to walk you through one more, but this should be enough practice. And if not, we can talk more about this later. All right, so we're going to do 5 and 8 together, and then you're going to do 7. So for question 5, again, guys should always be looking for your GCF first. So I'm going to take out a 2 first before I do anything. So I'll be left with 4p squared minus 8p minus 5. Now I can see I can do my factor by grouping. Master product. I have 4p squared times negative 5, which is negative 20p squared. And I want to see what multiplies to this value, but also adds to negative 8p. Okay, well, let's start thinking of some numbers. We have 10p and negative 2p. We have 5p and negative 4p, because remember, it has to multiply to a negative number, so one of them has to be negative. Well, 5 minus 4 is not going to get me to negative 8. 10 minus 2 is going to get me to positive 8, so maybe let's try negative 10p plus 2p. There you go. Negative 10p plus 2p is negative 8p. So I have my value that I can split the middle with. Leave this 2 alone on its own right now. So I have 4p squared minus 10p plus 2p minus 5. Take out your GCF for the first two and last two terms. So I'll have, let's take out a 2p times, we'll be left with 2p minus 5. Take out a 1, and we'll be left with 2p minus 5. All right, and then lastly, we'll be left with 2p plus 1 times 2p minus 5. Okay, guys, and that's it for that one. Let's quickly do 8, and you guys will do 7. And I'll write the other problems I want you to do. All right, again, I should always look for the GCF if there is one, and I don't see one. So let's just multiply to the back. So I have negative 150 w to the 4th. And we want to see what's going to multiply to negative 150 w to the 4th, but adds to this negative 19w. And let's see, negative 25w squared plus 6w squared. If I combine those like terms, I do end up getting this negative 19w squared. So now I can split the middle. I have 10w to the 4th minus 25w squared plus 6w squared minus 15. Take out the GCF of the first two and last two terms. So I see 5w squared. So take out the 5w squared. I'll have 2w squared minus 5. Let's see, we have take out a positive 3 here. So I'll have plus 3 times 2w squared minus 5. Again, we can color code. And I'll be left with 5w squared plus 3 times 2w squared minus 5. I'm going to write the answer for 7, and there are a few others I want you to try. All right, really quick, just on the last page, so we're on page 31 here, I want you guys to try 11 and 13, and I'm about to post the answers right now, but you guys need to show the solutions. All right, guys, those are the solutions for, those are the answers for 11 and 13. Please provide your work, and we can talk about it some other time, whether we do it over extra help or in class. All right, talk to you soon.